Hey class, this is Ms. Roberts, Shasta High School, and I'm going to be looking at problems 96 through 102 in Chapter 8. First question, 96, says write a possible exponential function in y equals a times b to the x form that represents each situation described below. So the first one, A, has two properties. They're telling me that it has a y-intercept that's located at 0, 2, and they're telling me that it also goes through the point 3, 128. So let's consider this. So with that information, right, I know one thing. I know that this is the 0th term of this. If this exponential function was a geometric sequence, right, that would be the 0th term. And I know that we're looking for something in the form y equals a times b to the x. Well, the 0th term gets located here. The other thing that we can do is we can use the x value and the y value from the other point to plug into this equation and then attempt to solve for b, because that's the only parameter we don't know. Remember, in an equation like this, we have parameters and we have variables. The parameters are the values that lock this particular exponential curve into a specific shape. So A and B are the parameters. Once we have those parameters in place, then we pick values for the variable x, right, the independent variable, and as we pick those values for x, it determines what y's would be. So let's go ahead and plug in what we know. We can say that y would equal a, we know, is 2 times, b, and then I know that x is 3. I forgot I'm going to put in that y is 128. So we've got 128 equals 2 times b to the third power. So if I want to get b cubed alone, I'm going to divide both sides by 2. So I didn't leave myself enough room here. I'll take 128 and I will divide that by 2, and that's what b to the third power is. And I'm going to use my calculator to get raise both sides of this to the 1/3 root, because if I raise both sides to the 1/3 root, that's how we're going to undo this. Oh, and before I do that, let me quite embarrassingly divide both sides by 2. Oh yeah, 64. Oh, I don't think I need to I think I know what this is. I think it's not 8. It's 4. 4 times 4. Maybe it's 4. Let's see. I get 64 is b to the third. So if I was to guess, I think the answer is 8. So 8 to the third power. No, it's not 8. I think it's 4. 4 to the third power is 64. Okay, so I know that b is the number 4, but how would I figure that out if I didn't know it ahead of time, right? So one of the things we've looked at is the fact that I can take this equation, 64 equals b to the third, and I can raise both sides of this equation to the 1/3 power. So if I raise this to the 1/3 power, that will just give me b to the raised to the third raised to the 1/3 is just plain old b. And on the other side, when I take 64 and raise it to the 1/3 power, apparently it's going to give me 8. So I want you to understand the difference, right? The first time I said, oh, no, it's not going to give me 8. I keep thinking that 8 squared is 64. It's going to give me 4. So the difference is, before I guessed it was 4 and I did 4 to the third. Now notice I'm not going to enter 4 anywhere. I'm just going to say, well, what is 64 raised to the, and I'm in my exponent now, rather, to the 1 divided by 3 power. And you can see 64 to the 1/3 power is 4. So yay, b is 4. Other way I can get that is I can take the third root of both sides. So that would look like this. On my calculator, I would hit the number 3, and then you hit math and option number 5. You can see it puts a little 3 inside the root index there. Not quite as small as I'd like it to be. And then I would say 64, and it would say, oh, the third root of 64 is 4. So I know that b is 4, and I also know that a was 2. I knew that from the beginning. So my answer to this is y equals 2 times b is 4 raised to the x power. So I could put parentheses, or I could not. Y equals 2 times 4 to the x power. So they're asking me to do the same thing. This time that it's going to pass through the point 0, 4 and 2, 1. Pretty similar process, right? passing through the point 0,4 also happens to be the y-intercept. So I know the value of a is 4 right off the bat, and then I've got this x, y value that we'll use with the 2, 1. So y equals 4 times b to the x, and then I think the point was 2 comma 1. I better double check because that's just the kind of thing I would mess up. Okay, so my value of y is 1, and then I've got 4, and then I've got b. I don't know b, but I do know that x is 2. Fabulous. Okay, so now I'm going to divide both sides by 4, so I get 1/4 equals b to the second power. And if I take the square root of that, yep, I get that b is going to be, it could be plus or minus 1/2, but we would need to use just this positive root here. B would be 1/2. And I could check that on the calculator also. Couple ways I could do it. The cute way is to go ahead and enter a fraction. So if I hit alpha and then this y equals, grab the fraction template, I could have a numerator of 1 and I could have a denominator of 4, and then I could take that fraction and raise it, because I forgot to hit the square root key. I can raise it to the 1 divided by 2 power, which is to the 1/2 power, and it says, hey, you got a half. Perfect. So I know now the equation has to be y equals 4 times 1/2 raised to the x power. So, and that fits the 2 points we know, right? If I put in 0, is 0 4? Yeah, yes, it is. That's right. If I put in that x is 0, right? If I put x is 0 into that equation, 1/2 to the 0 power is 1, and 1 times 4 is 4. And if I put in 1, right, if I put in the number 1 for x, 1/2 to the first is 1/2, and 1/2 times 4 is the number 2. So those were the 2 points that we were given, and we are done with that now. I guess I'll write it. It's okay. Well, y equals 4 times 1/2 to the x power. Not enough room there. Let's move on. Question number 97. It says, solve the following system of equations. In other words, find values of a and b that make each system true. Be sure to show your work or explain your thinking clearly. Okay. First system, this is fabulous, right? B to the 0 power is 1. So because of that, I know that a must be the number 3. Because of that, I'm going to use substitution, and I'm going to plug in a 3 in for a into this second equation. That's going to give me 75 equals 3 times b squared. I will now divide both sides by 3. That will give me 25 equals b squared. And looking at the principal root of that, it has to be the case that b is 5. So this first equation is y equals 3 times 5 raised to the x power. The two values that I know have to be true. When x is 0, it has to give me 3, and it does. And the other value that I know, when x is 2, it has to give me 75. Well, 5 squared is 25, and 25 times 3 is 75. So it passes both of the 2 points I know. Part B, pretty similar setup, except this time I'm not going to easily be able to get the exact value of I can't easily get the exact value of a right off the bat. So what I'm going to do instead is I'm going to choose to solve each of these equations for a, and then I'm going to use the fact that in the context of this problem, a certainly equals itself, and we'll use the equal values method. So in this first equation, to get a alone, I'm going to divide both sides by b squared. So that means 18 over b squared is a. And for the second equation, 54 divided by b cubed is a. So I've got two values for a, two expressions rather for a, and I'm going to use the first expression on the left hand side. So instead of a, I'm going to write 18 over b squared. And over on the right hand side, I'm going to write 54 over b to the third power. Now, this is great. I'm going to multiply both sides of this by, you guessed it, maybe, oh, why is the red disappointing me? Like, that's too, let me go here. I'm going to multiply both sides of this by b to the third power. So there we go. I'm going to hit each side of this with a factor of b cubed, and just to be real explicit and helpful, right? I don't know that I wouldn't write all these steps, but b cubed, b cubed over b squared equals 54 b to the third over b to the third. So you can see both the left and right hand side got a factor of b cubed in the numerator. When I simplify the left hand side, this becomes 18b, and when I simplify the right hand side, that becomes the number 54. So 18 times b is 54, and the next thing I'm going to do is I'm going to take the number 54 and of course divide that by exactly 18, and when I do that I get 3. 3 times 18 is apparently 54, so that means that b is 3. What did I do as I went from this step to that step? Well, I divided both sides by 18. Can you do that? Yeah, if you have equal things and you divide by equal things, you get equal things. So b is 3. Now that I know b is 3, there's two different ways for me to figure out what a is, right? Either this equation or this equation, both work. So actually I'll just grab the calculator here. I'll go 18, look at that, Mr. Roberts, 54 divided by 18 is 3. 18 divided by, let's see, I think, what did I say? I said b was 3. Oh, it's right there in front of me. Yeah. So divided by 3 squared is 9. 3 squared is 9. So oh, geez. Did I really just do that to get the a was 2? Yeah, I did. And guess what? 54 divided by 8 is, no. What was it? Oh, divided by 27. Yes, because b is 3. So I'm going to take 54 and divide it by 27, and 27 goes in there twice, right? 27. And I get the a is still, so in both cases a is 2. Yeah, we know that. Why are we still, okay, so what's the equation? The equation is y equals a, my 0th term, times b, which is 3 raised to the x power. Again, I know that this has to satisfy two equations, right? So I've got x, I've got y. When x is 2, I better get 18. 3 squared is 9, doubled is 18, so it checks. And when x is 3, I better get 54. 3 times 3 times 3 is 27, and 27 times 2 is 54. So just a nice way to check that confirms that yes, this is indeed the equation, an equation, the form y equals a times b to the x that goes through both of those points. Let's move on. Here we go. Okay, Kristen's grandparents started a savings account for her when she was born. They invested, so I guess X is her birthday, right? Her 16th birthday, X would be 16. They invested $500 in an account that pays 8% interest compounded annually. Okay, not simple interest, but it is compound, but it's only compounded once per year. Okay, write an equation to model this. So if y is the number of dollars in the account, it's going to equal the 0th term times, now it's growing by 8%. So 8%, if I'm growing by 8%, my multiplier would be 1.08. If it was decreasing by 8%, my multiplier would be 0.92. But there's my multiplier. That's what I'm multiplying by every single year, that amount. And then how many times do I multiply by? It depends on how old she is, to the x power. How much money is in the account on Kristen's 16th birthday? So I am going to answer that question, but I'm going to answer it by entering 500. Let me do this. Actually, I'm going to do this as an equation. So I'm going to go 500, y equals 500 times 1.08 raised to the x power. Perfect. And then I'm going to hit second, and I'm going to go to the table. So you can see at year 0, year 1, all the years are here. All the years are here. I can go all the way down to year 16, 15. There it is, 16. And it says at year 16 it would have a balance of $1,713. That's a lot more than I said. I'm sorry, Kristen. So A was this, B is $1,713. And then it says, what are the domain and range of the equation you wrote in part A? Okay. Well, I guess that's kind of tricky. I mean, I could plug negative numbers into this, right? And if I plugged a negative number in, it's just going to get closer to 0. It's going to, I think, it's going to get smaller and smaller as I go this way. This way, it is decreasing. So these are just going to get smaller. And I know that there's a limiting value, right? These are never going to become negative dollar numbers. So I'm going to say the domain is, all real numbers. The domain. But the problem with saying that is in the context of this problem, it's just like, wait a minute. I can't go back in time, right? I mean, the function would take negative numbers and produce an output. But in context of this problem, I can't go backwards in time. So I'm kind of ambivalent about that. Certainly, in terms of the function, all reals go in there. And then in terms of the range of this function, I can't get negative values out, right? In fact, I can't even get 0 out of it. So I would say the range was RANGE was all values of y that are strictly greater than 0. I can't get 0. If I could get 0, I'd put greater than or equal to 0, but I can't get 0. It just gets closer to 0. And sketch a graph of this situation. Okay, I'm glad I put this in the calculator. I'm going to cheat and hit second graph. Oh, no, graph. And come along. Oh, I'm never going to see this. My window is going from negative 10 to 10, so I need to see $500. So I'm going to change my window dramatically. Whoops. Window. There. My x values, I'm going to actually start them at 0. And then my maximum x, I'll just go out to, well, we wanted to know about her 16th birthday, so I'll take it out to 20 years, to when she's 20 years old. Oh, no, not 200. And then for the y values, well, probably the smallest value I need to see is 500, so I'll make it start at 450, so I can see something down there. And I'll make it go to 1700 was where I was at, so I'll make it go to $2,000. Okay, so let me graph that. Yeah, pretty predictable. I mean, did we need to see that? So if I have to sketch that graph, I'll just sketch it right here. The important thing is that, and this is clearly a sketch, right? Clearly, it's important that I'm at $500 and somewhere around the age of, 16ish, which is weird, right? 1, 2, 3, 4, 5. I don't know. Scale it so you get to 16, but somewhere around 16, you got to be at about $1,700. So that's a pretty pathetic sketch, Mr. Roberts, but it's what I got, right? So at 16, at the age 16, it's $1,750. Right, moving on to question. Thanks, Kristen, and Kristen's grandparents for setting this up so we could talk about it. Next one says, graph and connect the points GHJ to form triangle GHJ. What is the area of this triangle? Okay, sweet. So I went ahead and copied these points over here because I typically make a mistake when I'm going back and forth. So G is at -3, +1. So here is the point G. And then I've got H is at 3, 1, 2, 3, and then up to 7. There we go. That's at 3, 7. And then, why didn't I put the values here? This is at, I'm going to go that way. So G was at -3, 1. And then J is at -3 and then up to 5. Okay. Gotcha. This is -3, 5. Okay. I'm verifying this. I'm trying to be very careful before I go on. So I'm looking at each point. G is at -3, +1. H is at 3, 7. That is H. And then J is at -3 and 5. There's J. Okay, so I got these 3 points, and the question is, what's the area of this triangle? This triangle? Yeah, this triangle that goes from there to there, there to there, and then back to right there. So a couple ways I can do this, right? I can think about the fact that this triangle is bound inside of a particular rectangle, and this particular rectangle has like a base and a height, and the area of this triangle is 1/2 times that base times height. So the area of that triangle is 1/2 the I think it is. I think it's 1/2 the area of that rectangle. No, it's not. It can't be the 1/2 the area of that rectangle. What are you talking about? Yeah, it's not. Well, I can do this, right? I've got a base. I'll call this the base of the triangle, and the height actually is not. The height is not along any one of those orange lines. The height is this purple line right here. So the length of that purple line is the height of this triangle. So I've got a height and I've got a base. Well, the base is the difference in the y values between point G and J. And that is, there's a 5 and a 1. 5 minus 1 is 4. And yeah, I can see, I'll put down that this is 4. This is the base. Oh, let me put that in white. This is the base of that triangle, and the height of it is the difference between, I guess I could do either point, J and what was this? A J and H. So the x values for J and H go from -3 to +3. So this is 6 units long, right? The height is 6 units long. So the area of this triangle is area of the triangle is equal to 1/2 times the base of 4 times the height of 6. So 1/2 times 4 is 2, and 2 times 6 is 12. So the area of triangle, what is it, GJH, or they called it something else. I'll write GHJ is, and then it was, oh, I forgot. Let's see, 1/2 times 4 is 2, 2 times 6 is 2. It is 12 units squared, right? So if you look at this grid, what I'm saying is it's 12 of these, right? If this is a unit squared, this is a unit times a unit. The area of that triangle contains exactly 12 of those things right there. There we go, 12 of them. Okay, that is it for that one. And then finally, we will move on to the second to the last question. No, actually, this is just 100. There's 3. It says the grocery store is offering a sale on bread and soup. Fabulous. Bread and soup. Soup and bread. Someone buys 4 cans of the soup and 3 loaves of the bread for $11.67. Someone else buys 8 cans of the soup and 1 loaf of the bread for $12.89. Okay, write equations for both individuals' purchases. Okay, so if I say that B is the cost of a loaf of bread that's on sale, so one of these loaves that we're talking about, you don't go and pick up not that loaf, that one's not on sale, but the one that's on sale, right? If B is the cost of one of those loaves of bread that we're talking about, and S is the cost of a can of soup, not that soup, the one that's on sale, right? Then this has to be true, I think. So the first person bought 4 cans of soup, so that would look like 4 times S, and then plus 3 times the loaves of bread, and they spent $11.67. Okay, the other person bought 8 cans of the soup, so 8 cans of the soup, and just 1 loaf of the bread, and they spent $12.89. So solve the system. Solve this system. Solve it. So actually, as I look at this system, this is like, I think this is the first time in a long time that I've wanted to solve a system using substitution. And maybe I'm completely wrong in that. Maybe I'm completely wrong. But I'm going to get B alone in this second equation. So I'm going to say that B is equal to $12.89 minus 8 times S. That's what I'm doing. That's my story, and I'm sticking to it. Okay, so now that I know that that is what B is, I'm going to plug that into this top equation, and via substitution, I'm going to replace B with this expression that is equivalent to B. So I get 4 times S plus 3 times b. B is 12.89 minus 8s, and then that equals 1167. Great. Okay, so right now I can see I do not like the variable s. It looks like a 5 to me in almost every single one of these. So this is an s. Don't get this wrong, Mr. Roberts. This is an s, and this is not 45. This is an s. Okay, so first of all, 12 times or 3 times 1280. Okay, let me leave you. Quit. 3 times, and I got $12.89, $12.89. That is 38.67. So I've got 4s plus 38.67 minus 3 times 8 is 24s. Oh my goodness. 3 times 8, 3 times negative 8 is negative 24s. Okay. So, and then that is equal to $11.67. All right. I don't like how I've run out of room. So, oh, the beauty of these digital notebooks. Look at that. Put that below, and now let me see if I can keep solving here. So now if I simplify this, on this side it's 30, oops, back to the pen, it's $38.67, and I'm going to now subtract just 20 times s because I'm combining the negative 24s and the positive 4s, and that equals $11.67. So now let me take the $11.67 and subtract the 38.67, and I get a whopping negative $27. So that means that negative 20s equals negative $27. That means that s is divided by negative 20. It is $1.35. So a can of the soup is $1.35. And now for the loaf of bread. Well, remember our substitution, right? We got b alone already in the second equation, so I'm just going to use that. So the loaf of bread should be $12.89, point 89, and I should subtract from that 8 times s, so minus 8 times, and s is right there, and I get 209. So the cost of a loaf of bread is $2.09. Now, of course, all this work, it would be so silly not to check my answer against the original problem. Because I'm so close, but maybe, you know me, maybe I made a little mistake here and I'm not going to see it. So let me go ahead and check it. It says 4 cans of the soup. Okay, so 4 times the cans of the soup right there. I don't even have to enter that, right? I just go up and grab it. Will you go up? 4 times his cans of soup, and 3 of the loaves of bread plus 3 of the loaves of, I have to hit times. 3 times the loaf of bread cost gives me, please, 11.60. That's correct. So it worked for that one. And then the other one is if I have 8 cans of the soup, so 8 times, go get the can of the soup, $1.35. Right, the soup is $1.35. Go up there. Good. 8 times the can of soup plus just a single loaf of bread. So a single loaf of bread is right there. So 8 times the cost of 1 can of soup plus a single loaf of bread gives me $12.89. So not only, did I get these, but these totally check, and I put a smiley face here because it's correct. And then question 101, review the meanings of inequality symbols in the box at right. So when I see this little symbol, I know that means less than, right? So I could say like 3 is less than 5. Less than or equal to is it's just this less than with the line underneath it. This is greater than, and this is greater than or equal to. Okay, thank you. I have reviewed that. Check. Now what am I supposed to do? It says then decide if the statements below are true or false. 5 is less than 7. That is true. That is true. factorial. No, it's just true. How about this? 0 is less than or equal to 0. That is also true. 16 is less than or equal to negative 16. No. 16 is greater. This is false. F-A-L-S-E. That's not true. Let's go over here. Negative 2 is greater than or equal to 9. That's clearly false, right? We would say that negative 2 is less than or equal to 9. How about negative 5 is greater than negative 10? Oh, that is true, right? Negative 5 is further to the right on a number line, so this is true. Negative 5 is greater than negative 10. And finally, 1 is greater than 1. No, 1 is not greater than 1. 1 is equal to 1. It's not greater than itself, so that is false. So I know why these are coming up, so make sure you understand those statements and you can decide if things are true or false just like that. And then the final question, number 102, it says carefully examine each diagram below and explain why the geometric figure cannot exist. It's impossible. That cannot be. Support your statements with reasons. I love that, with reasons. That's so cool. It's like reasons, right? No, support your statement with just your emotional feel of the situation. I feel that this can't be. No, a reason. Here's my reason for this. If I look at this, I've got a 4 and a 4, and then next along there is this 5, and then there's a 5, and then finally I got this 7, right, and I got this 7. So as I go around the circle, it's clearly a 4, 5, 7. Those triangles are congruent to each other by side, 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 right? That is one of our triangle congruence conditions. The problem that I have is in between the 4 and 7 sides, right, between the 4 and 7, those angles have to be congruent. So I would say, hey, look, they're not. You're telling me that one's 80 degrees and the other one is 50 degrees, and these must be congruent because they're in that corresponding location of the triangle. So this is an impossibility, right? This is not something that could ever that this triangle could not exist. Let's go to B. Okay. Ooh. Okay, these two triangles are clearly congruent by what we would call side angle side. So if you look at it, there's this side right here, and it's matched with this side, the ones with 2 tick marks. And then I've got, let me see this. That's the biggest that goes. How's this? That's the biggest that goes. So this side right here goes with this side right here, right? And then they've got this angle in the middle marked congruent, right? It's 50 degrees on both of them. So by side angle side, they're congruent. Well, take a look at this. In corresponding positions, ooh, I still feel like it could be true. Well, okay. It would be true if this angle, right, can be 40 degrees. Because it would have to be 40. And this angle right here would have to be 80 degrees. So here I think my problem is if I take 50 and I add 80, I get 130. And if I take 130 and I add 40, I get 170. That is a problem because if I've got a triangle, right, the 3 angles in the triangle have to add up to 180 degrees. So I can go from the 50 to the 80. This angle must be 60 degrees, right? Just because of the triangle angle sum theorem. The 3 triangles have, but it's not. If they're congruent, the congruency is saying it has to be 40. And this angle right here, it would have to be, let's see, that's 90. This would have to be a 90-degree angle, right? But it's not because the congruent triangles is saying it has to be 80. So again, this is a situation that is impossible, right? That's not French. I don't know. Okay, let's see. Look at this one. Oh, no. Wait, maybe. No. So here's what I'm noticing. If this is a line, and I think that is a line, right? And if this is a 90-degree angle, they're showing me that's a 90-degree angle. That means this would also have to be a 90-degree angle. Okay, well, those 2 angles are congruent to each other because if 2 angles have the same number of degrees, they're equal. 90-degree angles have 90 degrees, and things that are 90 degrees are congruent to each other. Also, by the reflexive property, this segment down the middle is congruent to itself. So these two triangles would be congruent by side, and then angle, and then side. Well, that's fabulous, except then this side right here, this side and this side that I marked in green would have to be the same, right? They would be corresponding sides. And you can see again this craziness that on one side it's 12 and on the other side it's 10. So these could not be congruent triangles because 10 and 12 are not the same, and they would have to be the same. All right, let's move on to D. Okay. On D, they have indicated that these triangles are, oh, get away keyboard. They've indicated that these triangles are, they're isosceles triangles, right? I've got a pair of sides that are the same. Well, if you've got an isosceles triangle, the base angles would have to be congruent to each other. And because 60, right? Because 60 is not equal to, I'm sorry, 50 is not equal to 60, this cannot be, right? Those two angles would have to be the same in an isosceles triangle. How about over here? Dude, this is the same problem, right? This is not the same problem. This is the same problem because because this right here is forcing the entire, and I should be careful, it's the bigger triangle, the whole triangle, right? It's forcing the whole triangle to be isosceles. And again, with this thing right here being 50 and this one being 60, they would have to be the same. I think that's the same problem. Let's look at the last one here. Yes, they clearly share this side, right? So because that side is shared by both, it is definitely congruent to itself. So these two triangles are congruent by side, and then this angle, and then you can see they both have sides that are 15, right? So by side, angle, side, those triangles are congruent to each other, right? By SAS congruence. And I could write a flowchart proof if I wanted to. Well, if they're congruent by SAS, that means that all of their corresponding parts have to be the same, and that would imply that these two sides, this side that's 13 and this side down here that's 14, would have to be the same. They're not the same, so that's our impossibility, right? Because they are definitely congruent. So because of that, these sides would have to be the same, but 13 inches or 13 miles or whatever those units are is not the same as 14. It's just another case of sadness. So that is the end of this assignment. We went all the way to problem 102. Guys, the point for you to do homework every night is for you to get mathematically strong. So please do not abuse these lessons and just kind of passively sit by. Be really active, engaged, and get strong. Get strong. I look forward to seeing you in class.